Well, we're going to get started on the following problems. These are going to be conversions where you need to find the number of molecules. And so this problem comes from number 65, page 132. Okay, and so just reviewing again how to find the number of moles. And when we're looking for how many moles, molecules that we need, it is always that there is in 1 mole 6.02 times 10 to the 23rd molecules. Okay, 1.62 times 10 to the 23rd molecules. Now that would be the same as if you were asking for atoms or ions or particles. Okay, so when we're counting the number of, okay? And so let's just go ahead and get started. I've already found the masses for us. And so we're just going to get started. So A, we're going to start with what we're given, which is 66.5 grams of water. Okay. Now, again, remember our conversion is in moles. And I made the comment the other day that remember, if in doubt, always go to moles. That's going to be your easiest thing to remember. And so for water, it is 18.015 grams of water for every 1 mole of water. Okay. Be sure you do your unit cancellations. And now we have moles, so I can now go to this conversion. So 1 mole of water has 6.02 times 10 to the 23 molecules. Okay, and so there is my setup. Be sure again that you follow your unit cancellations. So again, just kind of let your units tell you what to do, but you do have to remember that the average atomic mass or the molar mass is always the mass per 1 mole. And also Avogadro's number is always per 1 mole. And that way, if we get it in moles, then we can do a cancellation to take it from the grams to the molecules. Okay, the rest of it is just calculations. Again, I would multiply across my numerator. And I'm just going to take, just for ease, and you can actually put the whole thing in if you want. I've got a cheap calculator. It doesn't do exponential very well. So I'm just multiplying across. So I just went ahead and took the front 2 numbers and multiplied them together and then left my scientific notation, the 10 to the 23, and then 18 times 1. Again, just divide that out. Divided by 18. So what I did is I just put these 2 numbers again in the calculator. It's 2.173, but I only have 2 digits. So I'm going to go with 2.2 times 10 to the 23. And again, you could have put the whole thing in your calculator. And again, molecules of H2O. And my H2O, I don't know if you can see that. Okay. And that's going to be your final answer. So again, the things that you have to remember is when you're doing your molar mass, again, it is the mass per 1 mole. And Avogadro's number is always per 1 mole. So we'll do the next one, 389. If you would like, whenever you feel comfortable, to pause and go ahead and try to work it out on your own and see if you can do it, and then come back in and watch mine. Or if you are taking notes as you go, I would definitely watch me do the whole problem, and then you go back and write it out. But at some point, you probably need to try to work ahead of me and then watch the video so that you can see if you really know what you're doing, because just watching me is not going to be enough. Okay, you got to do it yourself and then check. Okay, so again, we're working with 389 calcium tetrabromine, carbon tetrabromine. Where did I get calcium at? It's been a long day today on that. So here we go. Again, I'm going to go from grams So 331.63 grams carbon tetrabromide to 1 mole carbon tetrabromide. Now, for those of you who are, okay, how did she know it was carbon tetrabromide? Carbon, bromine, they're both non-metals. So I'm going to use prefixes. Be sure we cancel out. And now I've got it to moles. And again, I'm going to molecules. So 1 mole is 6.02 times 10 to the 23 molecules. Okay, write too big and then run off. Okay, so again, it's all labeled there. Okay, and the rest is just calculations. So we're going to take the 389 times 6.02. So I get 2341.78. Again, if you put it all in your calculator, you're going to see just a slight bit difference on that because it'll already be in scientific notation, but the value should be the same. I'm just showing you my math calculations here. So this becomes 7.06. I need 3 digits. My next number is a 1. And then times 10 to the 23. Again, molecules. Put it under it so you can see it. CBr4. Final answer. Okay, let's do one more. Again, I would say if you think you've got it, pause the video, you try it on your own, and then come back in and see if we agree. So 22.1 grams of oxygen. Oxygen has 32.00, because I have 2 of them, for 1 mole. And now I've got it to moles, I can go to my molecules. Okay, so there's my setup. Again, the rest of it is just calculations again. So I'm just going to go ahead and put the whole thing in this time. Oops. Missed a decimal. Okay, so when I put all my numbers in, I got 0.011, I need 5 times 10 to the 23. Again, you probably put yours in different. So 1.15 times 10 to the 22nd. Okay, again, check my math for me. Always when I try to do some things in my head, mess up. Okay, check that and see if I got it right. Let me know if I got it wrong. So this is how we convert from grams to molecules. Now, I did not and may not have the chance to do a separate video on how to go the opposite direction. But of course, if you're going from molecules, then it's Avogadro's number per 1 molecule, or Avogadro's molecules for 1 mole. It's going to be flipped upside down. Would be your first step. So you'll have the same steps. They're going to be in a different order, and they're generally flipped upside down when you're going the opposite direction. So the same way with the gram to mole conversions that we did, when you're going from moles to grams, it's the same thing. It's just flipped upside down so that our units cancel. Okay, so again, watch the units. Let the units tell you what you need to do. If they're not canceling, then you're definitely doing them wrong. And of course, just because they cancel doesn't mean you're doing them right, but at least that's a first step in there. So this is going from grams to molecules.